Hello. Today, I'm going to be giving a demonstration on PhET interactive simulations. So these are simulations for teaching and learning. So PhET stands for Physics, Education, Technology. And so it really started out on just physics simulations, but since then they've added chemistry, math, earth science, and biology simulations as well. So for today, we're going to be focusing on grade 9 science, and we are looking at these building circuits. So I'm going to jump straight into the physics tab. So once we're here, you can see on the left-hand side that there's a bunch of different filters. So right now we are filtered for all of the physics simulations, but you can see all the other subjects there as well. You can also filter for grade level. So there's elementary school, middle school, high school, or university. There's also compatibility filters. So HTML5 is what's going to run on everything. So tablets, laptops, mobile devices, iPads. So HTML5 is going to run on everything. There's also access and inclusion filters. So there's alternative input, interactive description on mobile devices, sound and sonification, pan and zoom, and voicing. So just to compare, for example, the normal modes versus Fourier making waves. So you can see what types of access and inclusion features they have. So not every simulation is going to have all of these features, but they're going to have the ones that make it inclusive for the most amount of people. Lastly, you can filter by language. So there are over 120 different language translations. And again, not every simulation is going to have every translation. So that's why you can filter for the different languages. So we are focusing on just circuit building. So I'm going to actually unselect all of the physics filters, and I'm just going to click on the circuits one. And that's going to make it a lot easier to find what I need. So I'm going to click on the DC circuit construction kit because direct current is a part of the grade 9 curriculum. So I'm going to click in. And so here, if you press the play button, it will play the simulation. But before we do that, I'm going to show a few more features of this website. So if you scroll down in the About tab, it's going to show different screenshots of the simulation. It shows the topics, sample learning goals, the inclusive features, and the system requirements as well. Now, if we go into the next tab, the teaching resources, so it's going to have a document for teaching tips. So you do have to sign in and create an account, but it's super simple and free. So I do have an account. I'm just going to quickly sign in to show you the resources. So the reason why you have to sign in is so that students don't have access to this. So for teacher tips, it shows you what every tool in the simulation does. And then there's also usually a video that shows you exactly how to use a simulation and maybe what kind of issues your students might run into. If we go into the next tab under the activities, there's a whole list of resources that's either added by PhET instructors or other teaching professionals as well. So you can kind of see that there are some lab documents, some homework, some multiple choice. So all of the types are there and for you to select from. Lastly, the last tab is translations. So this shows you all of the different languages that the simulation can be translated to. So I'm going to invite you to take a pause here and either go through this simulation if you'd like, or to maybe look at some different subjects, maybe a subject that's applicable to you, and to just go through and see what teaching resources are available. All right, hopefully you got a chance to take a look around a bit now that you know more about the features of this website. So now I'm going to click into the simulation. For this simulation, there is an intro. So again, if you want to pause and do the intro, you definitely can. I'm just going to click straight into the lab. So I'm just going to be showing you just the features of the simulation. So on the left, there's a bunch of different materials for you to create your circuits. So to select different materials, you're going to click and drag. And then again, if you want to change the shape or location, you just click and drag. To scroll through, there's a bunch of different materials. So you can just click the up and down buttons. Another feature is down here on the left. So you can have the circuit to look like real life, or you can have it to look like circuit diagram drawings. So this is super helpful for students because when they're drawing circuit diagrams, this is what it looks like. Another feature on the right here is you can either show the current or not show the current, and you can show them as electrons or just the conventional. So you can also include labels. You can either have the labels or you can kind of quiz your students if they have the background knowledge to hide the labels so that they have to know what each symbol means. There's also values. So as you can see here, our battery is 1,000 volts, or you can hide the values. Then there's a voltmeter. To put it in to the circuit, you just click and drag again. But then to connect it, you have to click and drag these electrodes. So you can see that when it's not connected to the circuit, it doesn't read. But then once it does, it reads that 1,000 volts, like we know from our values. Another device is the ammeter. So again, just click and drag. And this one measures current. So because we have an open circuit, it's actually not going to read a current right now, but Grace will touch upon that later. There's also advanced options, which I'm not going to go through because it's just, we're touching upon grade 9 science. But for upper grades, there is advanced options as well. So now, again, I'm going to invite you to pause the video, maybe play around with this specific simulation if you haven't already.
The lesson we plan using PhET simulations is targeted towards a grade 9 D-Stream science class and focuses on the physics strand of the course. This strand covers principles and applications of electricity, and our lesson centers around properties of current electricity and circuits. After completing this lesson, students will be able to use the direct current circuit construction kit in the PhET simulator to construct various series, parallel, and combination circuits, correctly apply the ammeter and voltmeter using the circuit construction kit to compare and contrast the current and potential difference in series and parallel circuits, and finally, test the conductivity of various materials included in the circuit construction kit. After giving a lesson on how to construct series and parallel circuits, students will be directed to this page where they can build their own. When constructing the circuits, students will be given specific parameters to follow, such as including a switch. Students will then have the freedom to construct their circuit in different ways as long as the parameters are met. The students will begin the activity by making a series circuit. The easiest way to do that would be to start off with a battery. So we drag the battery. This counts as our energy source. Then we need a conductor, which is a wire. Then we would attach it right here. Then we would need a load. In this case, we're using a light bulb, which is going to convert the potential energy into into light energy. Then we connect our wire here, just like that. And then we need to connect like that. And that is our simple series circuit. We know it's working because our light bulb is turned on and the electrons are flowing. Next, the students will be instructed to make a parallel circuit. So we start off by making it in the same way. We attach a battery to a wire. And the way that a parallel circuit differs than a series circuit is that there are multiple pathways for the electrons to flow. So I'll show you. Okay, so right now we have one pathway. One pathway looks like that. Now we're going to have another pathway. So we're going to attach another load, another light bulb. Okay, just like that. And now we have two pathways for our electrons to flow. So we have this pathway here, and then we have this pathway here. Before trying this activity, students will understand what an ammeter is used for and how to attach it to different circuits. So the ammeter function is over here. You would take it and drag it, and you would attach it to anywhere along your circuits. In a series circuit, it doesn't matter where you put the ammeter, the reading will always be the same. This measures current, and it's measured in amperes. And like I said, anywhere you put it along your circuits, it's always going to be the same reading. In a parallel circuit, the current is split between the loads. So for example, if I put my ammeter right here, that's going to give you the total current for the entire circuit. But if I put it along this pathway, it would be divided in two. Same with this pathway, the total current divided by 2. So that's how you use the ammeter. The next part of the activity would be using the voltmeter. So this is similar with the ammeter. Students will be given some background in the lesson on how to use the voltmeter, what it measures, and how to hook it up to different circuits. So how you use a voltmeter is you hook it up to different points in your circuit, and it's going to measure the potential difference across those 2 points. So you would take the black end, put it right there, the red end, put it there, and it's going to give you the total voltage. This is where you read it. It's measured in volts. Potential difference and voltage is the same thing. In a series circuit, the total voltage is split between the different loads. And in a parallel circuit, the voltage is the same all throughout the circuit, no matter where you were to hook it up. The lesson before the activity, students will understand what readings they should get on their ammeter and voltmeters. So if they get a different reading than expected, they will have to use critical thinking skills to solve the problem. For our final learning goal, students will need to learn how to test the conductivity of different materials. The different materials listed in the construction kit are a dollar bill, a paper clip, a coin, an eraser, a wire, and a pencil. So the way they would do this is they would build a simple circuit. Here's a wire. Here's our battery. Okay, here is our load. And then we would hook up one of our materials. Let's try a coin. Okay. And then if your circuit turns on, our light bulb turns on, we know that the coin is a conductor. And we know that because the electrons are flowing through. If we were to try an eraser, okay, we see that the electrons are not flowing, so we know that the eraser is not a conductor.